Hey Rihanna, I'm recording this for you here so that way we can go over the last problem, number 11, while I've still got it up on the board for the day before I erase it. Okay, so in the original diagram you have a three-charge problem, Q3, Q2, and Q1. And the question asks you what direction and what is the amount of force that Q1 is going to be moving with. Okay, now I'm sure you probably did the problems already where you figured out what the two components were. Okay, the component for Q2 pulling on Q1 is 0.54 newtons to the left, and as you can see the red arrow there already. Now, for Q3 on Q1, Q3 is pushing away Q1 with an amount of 0.405 newtons. That's the amount of force it's pulling there. But here's the thing. Q3 and Q1 are like charges, so Q3 is pushing Q1 down and to the right with a force of 0.405 newtons. So what we need to do is figure out what is the net force of Q1. So we need to take 0.405 and divide it up into its components in order to figure out if the object is going to be moving left or right, and then figure out how far down it's going to be going. And then from that, figure out what the angle is that it's going at. Okay, so we're going to start by breaking up 0.405 newtons. According to the diagram to start with, it looks like we have pretty much an equidistant triangle as according to your problem here, so two 45-degree angles and a 90-degree angle. So when we set up Q1, Q1 would be up at the top of the triangle here, going 45 degrees at 0.405 newtons. That's the effect that Q3 has on Q1. So 45 degrees and 0.405 newtons. Okay, so when we set up our triangle for y and x, we can use the sine and cosine functions. So we use the sine of 45 degrees equals x over 0.405 newtons to solve for x. When we do that, we get that x equals 0.286 newtons. Okay. So that means Q is being pulled to the left 0.54 newtons and to the right 0.286 newtons. So that means Q2 is going to win the battle of left and right. It's the stronger force. So we have to subtract 0.286 from 0.54. That's what's being done here. 0.54 minus 0.286 gives us 0.254. So Q2 is pulling Q1 0.254 newtons to the left. Now when we solve to find the y component of the triangle, the y component, when you do cosine 45 degrees equals y over the hypotenuse, we also end up getting 0.286 newtons. So we now know that Q1 is being pulled to the left 0.254 newtons and down 0.286 newtons. So we set up a right triangle to figure out what the angle is there, where Q1 is at. So Q1 in the upper right hand corner there is where the charge is at. It's being pulled down into the left. We want to find the angle and the amount of force. So to find the amount of force, use the Pythagorean theorem. A squared plus b squared equals c squared. So 0.286 squared plus 0.254 squared, and then you take the square root of that. When you do that, you get C to be 0.382 newtons. So C is 0.382 newtons. And we know we're going down to the left. Okay? So the last thing we want to do is find the angle. Okay? So I can use...
High school staff, middle school staff, please report to the library. High school, middle school staff to the library.
So now I see I can find the angle by doing the arctangent, because tangent equals opposite over adjacent, and that's what I have here. So this would be the opposite from that angle. This side would be adjacent. So I have to do the arctan of 0.286 divided by 0.254 to get my angle. When I do that, I get 48.4 degrees, and it is going in a southwesterly direction. So to end up, we are going 48.4 degrees in a southwesterly direction with a force of 0.382 newtons. I'll send this to you. Hope that helps. Please feel free to come talk to me if you have any questions. Mr. Nall signing off.